Welcome to Brain Vision.
Well, we have two fishes, A and B. The big one's mass is 15.0 kilogram. So MA, that's the mass of big one, and it's equal to 15.0 kilogram, right? And the small one's mass is 4.50 kilogram. So small one's mass is 4.50 kilogram. Well, taking the initial direction as the positive direction, we have the big fish velocity before the collision. Well, before the collision, the velocity is VA1, and that is equal to 1.10 meter per second, and the small fish velocity before the collision is B1, and that is equal to 0 meter per second. Well, we know that in collision of all kinds, since there is no external net force on the system, the total momentum before the collision equals the total momentum of the collision. Therefore, P1 is equal to P2, right? Momentum before collision is equal to momentum after collision. Well, if the collision is between two particles, A and B, then we get PA1, right, plus PB1 is equal to PA2 plus PB2 plus PB2, where the momentum of a particle is given by, so momentum of a particle is given by mass times velocity. Well, let's call this equation number 1. Now we can write the collision equation in the following form. Let's write down here mass of A times VA1 plus mass of B times VB1, and that is equal to mass of A times VA2 plus mass of B times VB2. And let's say this is equation number 2. This equation is equation number 2, right? Now let's do part A. Now we do part A. Well, neglecting water drag effect means that there is no external net force, so the momentum is conserved. Also, after the collision, the big fish eats the small one, so they have the same final velocity. So we have VA2 is equal to VB2 is equal to V2. Now we plug our values for MA, MB, VA1 and VB1 and substitute for V2 into equation number 2. So we have 15.0 into 1.10 plus 4.50 into 0, that is equal to 15 multiplied by V2 plus 4.50 times V2. And solving for V2 is equal to 15.0 times 1.10 divided by 15.0 plus 4.50, and that is equal to 0.846 meter per second. And now we do part B. Well, let's calculate the kinetic energy before the collision. So K1 is equal to Ka1 plus Kp1. So kinetic energies of A and B. Now that is equal to 1 divided by 2 into 15.0 into 1.10 whole square plus 0, and that is equal to 9.075 joule. And the kinetic energy after the collision is given by, so kinetic energy after the collision is K2, and K2 is equal to Ka2 plus Kb2, that is equal to 1 divided by 2 into 15.0 plus 4.5 into 0.846 whole square, and that is equal to 6.981 joule. And now change in kinetic energy is equal to K2 minus K1, that is equal to 6.981 minus 9.075, that is equal to minus 2.094 joules. Since the fishes are in the water, there is always a force exerted by water opposite to gravity. So we can neglect the gravitational potential energy. Therefore, the kinetic energy is all the mechanical energy. Therefore, the dissipated mechanical energy during this meal is 2.094 joule. So dissipated mechanical energy is equal to 2.094 joules.